Hi everybody, Mrs. Pesic here. We are looking at section 4.6, graphs of other trig functions. Your goal in this section is to graph secant functions, cosecant functions, tangent, and cotangent functions. So there's the other four trig functions that we're going to work on in this section. And today we're only going to look at what I'm calling part one, which is just graphing secant and cosecant functions. You are going to all be experts at this because you're getting to be very good at graphing cosine and sine functions, and they are very closely related, as you will see. So you can obtain the graphs of cosecant and secant functions from the graphs of the sine and cosine functions. Remember that cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So let's just recall, what do we mean by reciprocals? Like the reciprocal of 4 is going to be 1/4. All right, and the reciprocal of 3 is going to be 1/3. The reciprocal of 2 is 1/2. The reciprocal of 1 is itself, right? That's 1. The reciprocal of 1/2 is going to be 2/1, or 2. The reciprocal of 0.1, which is 1/10, would be 10. The reciprocal of 0.01 would be, that's 1/100, so the reciprocal is going to be 100. 0.001 is 1/1000, so the reciprocal is going to be 1000, and you get the idea here. If it's 0.0001, then we're talking about the reciprocal being 10,000. But what's the reciprocal of 0? Well, the reciprocal of 0, 1/0, is undefined. Right? So when we have undefined as a value for the graph, then we are not going to be able to plot a point at that point. All right. So let's back up though and talk about the range. What's the range for cosine? Remember our cosine graph. Let's see, here's pi, here's 2 pi. Remember our cosine graph started at a height of 1 and had a depth of -1 at pi, and then was back up to 1 at pi. So it's kind of like this bowl shape, and we said that the range is basically going from this -1, right, up to a height of 1. So that was the range, -1 to 1. So what's going to be the range for secant? Well, we want 1 over all of those values. So if we want 1 over -1, that is going to be -1, but what's another number in this set, like -1/2? Well, the reciprocal of that is -2, right? And maybe +1/4. Well, the reciprocal of that is +4, and so on. So as we're going to see, the range for secant is going to be all real numbers except for anything in between -1 and 1. So our range is going to be -infinity to -1 with a bracket. Slide this over a little bit. Union with bracket 1 to +infinity. All right, that's going to be the range for secant. All right, so let's actually explore that with the TI Inspire. Let's see what's going on when we're graphing this. So if we graph, let's graph cosine first. So if I graph cosine of x, okay, so let's try this again. Push the trig button. I want cosine of, trying again. There we go. I want to push trig button, and I'm graphing cosine of x. All right, and remember, let's change this menu, window zoom, and let's go to zoom trig. That gets us going from -2 pi to 2 pi. And then really, I want to see, how does this graph cosine compare to its reciprocal secant? So I am going to push the tab button, and I'm going to try and graph secant now. So I'm going over here. I want to graph secant of x. And look at what's happening. Anywhere where there was a, kind of like a hill, right, on the cosine graph, we're going to end up having a valley coming down to meet it. So here we had a valley for cosine, and then we had a hill coming up to meet it, and so on. So you can see from this graph that the range for the secant graph is going to be anything from +1 on up, or anything from -1 on down. All right, but we're not going to see any secant points plotted in this region between -1 and 1. All right, so that's why we're going to say that our range for that's not what I wanted to show you. Our range for secant is going to be negative infinity to negative 1, union with 1 to positive infinity. All right. So in order to graph secant function, we're still going to first graph the cosine function. So hopefully you're getting to be experts at this. So I know that my cosine function goes through these key points that we talked about in class. And I'm going to put the cosine graph in a dotted way, and I could keep that going over here as well. And so here's my cosine graph, and I'm going to graph that dotted, and then wherever the cosine graph here, wherever it was hitting its midline, right? Here's my midline. Wherever the cosine was hitting the midline, I'm not going to have any points, right? Because the reciprocal of 0 is undefined. So I'm going to have what's called a vertical asymptote for my secant graph at these points, all right? At negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2, and so on. So when I want to graph a secant graph, any place where there was a valley for the cosine, I'm going to have a secant hill to kind of come up and meet it right there, all right? The original graph didn't go quite down as far as I wanted. All right, so, and then again, if we have a hill on the cosine graph, we're going to have a secant valley come and meet it like this. All right, and we can just keep doing this over and over again, and that's really what the secant graph looks like. It's just kind of a series of like hill, valley, hill, valley, hill, valley, and so on. All right, so that is our graph. I'll put in these little pieces here. So that would be our official graph of the secant function between negative 2 pi and 2 pi. So what's the period of this graph? Well, the period of this graph is still going to be 2 pi, right? It's still going to repeat every 2 pi units. Right? If you picture, I've got this kind of down branch here, and the width of that down branch, that width from here to here is pi units. And then same thing here, I've got an up branch, and the width of this up branch is pi units, right? Pi units from here to here. So altogether, that's 2 pi units to get a down branch and an up branch, and then it starts repeating with another down branch and another up branch and so on. So the period is still 2 pi, and our formula for finding the period is still going to be 2 pi over b. And then this is asking, what about the asymptotes? Well, we see for the secant graph, our asymptotes are occurring at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and we could just keep listing them forever, all right? There is no horizontal shift. We didn't mess with anything here. We didn't put any parameters in or anything like that. So I'll just say, for a basic parent function of secant x, there was no horizontal shift, no vertical shift. All right, so let's take a look at a problem where we're graphing a secant function where we have some of those parameters in. In this case, we see, A's really still just 1, right? That's that number out here. B is 2, C is 0, D is negative 1. And the idea here is, in order to graph this, we want to do the hill and valley thing again. So in order to do this, we really want to graph f of x equaling the cosine of 2x minus 1. So really think of this, all right? So first of all, let's back up though. If I want the amplitude of the secant graph, let's go back and look at our picture here. The amplitude, remember, that means the distance from the midline up to the highest point of the graph. Well, that's not going to make any sense for a secant graph because there is no highest point, right? So that's kind of like a trick question. Anytime you see it for a secant or a cosecant graph, our amplitude is none. Right? Does not exist, NA, whatever you want to say. All right, the period, the formula is still 2 pi over b, In this case, our b was equal to 2, so we get 2 pi over 2 is equal to pi. All right, what about the horizontal shift? Again, our formula is still c over b, and so that's going to be 0 over 2, which is 0. Vertical shift, I will say that because of that d value, this whole thing is being shifted down 1. All right, and really the starting point, ending point here for these problems here, we're still going to be using the same formula that we did. That's the bx minus c equals 0 for our starting point. So let's just do 2x as our bx minus c equals 0, and I get x equals 0, so my starting point is 0. And my ending point, I'm going to set bx minus c equal to 2 pi. So I'll get 2x equals 2 pi, divide by 2, and I get x equals pi. So I know my ending point is pi. Let's hold on the asymptotes for a moment. So I'm just going to write wait. We're waiting on that for a minute, and I'll explain why. And we still need our step, though. Formula for step, as you know, is the period divided by 4. So that's pi over 4. So we're going to start with filling in x in the top. That's our column header here. And then we're going to have our starting point of 0. We know our ending point is pi. And what are we really graphing? I want you to graph this guy, or at least fill up your table with the graph information for cosine instead of secant. So we want to have this column header here be cosine of 2x. Okay, and so the increment is pi over 4, that's our step. So I'm going to add pi over 4 here, add pi over 4 again, I get pi over 2, add pi over 4 again, I get 3 pi over 4, add pi over 4 again, and I get to that ending point. Now in our second column, again, remember, we're going to fill this in with our cosine information. So cosine pattern, the key values are 1, 0, negative 1, 0, 1. And then our next column is going to be cosine of 2x. We don't have an a to worry about, but we do have a d to concern ourselves with. So I'm going to make that column minus 1. I need to subtract 1 from each of the second column values. So I'm going to have 1 minus 1 is 0. That's going to be a negative 1. That's a negative 2. That's going to be a negative 1. And that is going to be a 0. Right? I subtracted 1 from each of the second column values. I really don't need this last column in my table. And now I'm ready to graph what we see here. And again, what am I graphing? I'm going to graph cosine first, and I'm going to graph that using a dotted line. So at 0, I want to be at 0. And at pi over 4, I need to be at negative 1. Pi over 2, I'm at negative 2. 3 pi over 4, I'm at negative 1. And at pi, I'm back to 0. Again, I'm going to make that a dotted shape. And again, it should look kind of rounded like a bowl shape like that. And I could keep that pattern going. I see what that pattern is. I'm going to keep that wave pattern going like this. And then here's the point I want to get back to. Remember I said let's wait on the asymptotes. Let's wait no longer on this, because what we're going to do to find the horizontal asymptotes is after we've made our table, we're going to look in the second column, always the second column. Highlighter, I'm going to focus just on this second column right now, and wherever I have a 0 in the second column, right, there's a 0 in the second column, there's a 0 in the second column, those are going to be my horizontal asymptote. Horizontal asymptote, horizontal asymptote. So I know on my graph I can draw in my horizontal asymptote at pi over 4 and at 3 pi over 4. So here's pi over 4, here's 3 pi over 4. All right, and remember, it's wherever your cosine graph is intersecting with its midline. And it looks like the midline for the cosine is here, right? And so my cosine graph is intersecting that midline at pi over 4 and 3 pi over 4. And I could go further and say at 5 pi over 4 and so on. All right? I'll put in one more, 7 pi over 4. And now, at long last, let's draw in the secant graph. And remember, that's the whole hill and valley thing. That's all you have to do. You don't have to plot any points. We're just going to say, hey, secant is going to come up like this to meet that valley shape on the cosine. And same thing here. It's going to come down. It's going to be a hill, valley that comes down to meet that hill, and so forth. All right, and so we can sketch the graph like this. And at least I have it graphed 2 complete periods worth. I've graphed it between 0 and 2 pi. All right, let's take a look at another one. So just to make sure everybody's understanding, this graph here is our secant of 2x minus 1. This graph here was just our cosine of 2x minus 1. But it's really, it's this graph that we're supposed to be graphing, right? Okay, let's take a look at another example of secant graphing. This time we've got -2 times secant of x minus pi over 2. All right, amplitude here. Remember, we don't want to say, oh, it's the absolute value of a. No, right? That's a big no-no on secant graphs. There is no amplitude because there is no highest point. We can't say, oh, the highest point minus the midline or something like that. No. So remember, when you see amplitude for a secant or cosecant, that's a trick question. You're going to say none, does not exist, something like that. Period is going to be 2 pi over b. So remember, a is -2 in this case, b is 1, c is pi over 2, d is 0. So the period is still 2 pi over b, which is just 2 pi. Horizontal shift is going to be our c over b. I'm going to write that over here. Horizontal shift is c over b, so that's pi over 2 over 1 is just pi over 2. And vertical shift, none, because our d value is 0. Our starting point, let's find that. That's bx minus c equal to 0, so that's x minus pi over 2 equal to 0. Remember, if I'm going too fast, you're going to pause this video, catch up to me, and then start it up again. I'm going to add pi over 2, so I get pi over 2. That's my starting point. My ending point is going to be found. This will start, so this is end. Ending point is bx minus c equals 2 pi. So I get x minus pi over 2 equaling 2 pi. Add pi over 2 to both sides, and I really have 4 pi over 2, and that's supposed to be a pi, plus pi over 2, and so I get x equaling 5 pi over 2. So that's my ending point. All right. So I know in my chart I can fill in pi over 2 here and 5 pi over 2 here. I do want to wait on the asymptotes. Wait until I have this whole chart filled out. But for right now, we can find the step. That's just the period divided by 4. So that's 2 pi over 4 or pi over 2. So if I add pi over 2 here, I get pi, just get pi, right? And then if I add pi over 2 to that, I get 3 pi over 2. Add pi over 2 to that, I get 2 pi, that's 4 pi over 2, and then I get 5 pi over 2. All right, remember, what are we actually filling in this chart? We are actually going to be filling in not the secant, but the cosine. So I really want to graph f of x equaling -2 cosine of x minus pi over 2. That's what we're going to be filling into this chart. All right. So here in this second column, I'm going to make this cosine of x minus pi over 2, because we know all of those key values for cosine. That's 1, 0, -1, 0, 1. And then I have an a value to consider, so that's going to be -2 times cosine of x minus pi over 2. And so I have to multiply all of these values by -2. So I'm going to get -2, 0, +2, 0, -2. I do not have a d value to concern myself with, so I don't need this last column in my table. But I do see that I do have to come back and take care of the asymptotes. So remember, we look at our second column, always the second column, and we're going to look to see where do we have zeros in the second column. All right, I see 0 at pi, and a 0 is occurring at 2 pi in the second column. All right, here it sure looks like the last column also had zeros for those same x values. But back in this problem, when we did this graph, the zeros in the second column were not the same as the zeros in the third column. So you always want to go with the second column. All right, and then I think we are ready to plot these points. Oh, I didn't write in these pi, 2 pi. I think we see a pattern here that we see could continue pi, 2 pi, 3 pi, and so on, or 0, negative pi, and so on this way. All right. So if I graph this here, I'm going to, remember I'm graphing the cosine first, so I want pi over 2 at negative 2. Pi is at 0. 3 pi over 2 is at 2. 2 pi is at 0. I'm a little bit off my graph, but 5 pi over 2 would be about here. All right, 5 pi over 2. And so I can draw in this cosine graph, nice and rounded. I can extend this a little bit. 2 to the left, 2 up, 2 to the left, 2 up, 2 to the left, 2 down, 2 to the left, 2 down. So I can keep this pattern going. All right, like this. And where were those vertical asymptotes? They're going to be at pi and at 2 pi and so on. So I can draw those in, vertical asymptote at pi, vertical asymptote at 2 pi, also at 0, negative pi, negative 2 pi, and so on. All right, all right, so remember, this graph that we just did was the graph of f of x equaling negative 2 cosine of x minus pi over 2. But now we want to graph the function f of x equaling negative 2 secant of x minus pi over 2. And so wherever there's a hill on the cosine, we're going to make a valley come down and meet it. And wherever there was a valley for cosine, we're going to have a hill come up to meet it. So we just basically have a series of, I'll refer to them as like an up branch, down branch, up branch, down branch. I mean, this one obviously would continue. I just didn't do the rest of the cosine there. All right, so the graph is looking something like this. All right. Okay, so, all right, so that's our graph for the negative 2 secant of x minus pi over 2. All right, let's switch gears and talk about cosecant. Cosecant is the reciprocal of sine. So just like we talked about the sine graph, and you know what the sine graph looks like, it has its basic shape looking like this. The range for the sine is still between negative 1 and 1. And that means that the range for cosecant is going to be everything, you know, everything up here, right? And everything down here. So the cosecant range is going to be negative infinity to negative 1, union with 1 to positive infinity. All right? And we can just, again, take a quick look on our calculator to see what this looks like. Clear the scratch pad. All right, so remember this was cosine and secant, and I'm going to add another page. Oh, I'm in Scratchpad. That's why that's happening. Okay, let's see. Let's try this again. I want to graph the sine function first. So sine of x, there's our sine of x function. I'm going to adjust my viewing window. Window zoom. I want zoom trig. All right, that's taken me from negative 2 pi to 2 pi. And I push tab, and now I can graph the cosecant of x. And again, there it is, graph between negative 2 pi and 2 pi. We have an up branch here and a down branch. That makes one complete cycle of the cosecant function. And then we have another up branch and down branch, right? So that's another period there, all right? So let's go back to our graph. So when we're graphing this by hand, we're going to graph the sine function in first. And hopefully you're getting really fast at graphing sine function starting at 0, 0. And like this, you have it extend between negative 2 pi and 2 pi like this. Wherever the sine graph is crossing the midline is where we're going to have vertical asymptotes. So we have vertical asymptote here at negative 2 pi, at negative pi, and at 0, and at pi, and 2 pi. Remember, that's not the same as the vertical asymptotes for the secant graph. So our vertical asymptotes here are negative 2 pi, negative pi, 0, pi, 2 pi. The period is still 2 pi, or 2 pi over b, but in this case, we're just talking about the parent function, so b is equal to 1. Horizontal shift, vertical shift, none, and we haven't done anything to this parent function yet. All right, but let's start doing that now. So we're going to look at this graph, 1 plus 2 cosecant 4x. In this case, it looks like the A is 2, the B is 4, the C is 0, and the D is 1. All right, and so amplitude, again, trick question, does not exist, not applicable. All right, the period is still 2 pi over b for the cosecant function, so that's 2 pi over 4 or pi over 2. Horizontal shift is c over b. Well, that's 0 over 4, so that's going to be just equal to 0. Vertical shift, I'm going to say this is shifting up 1 unit. Starting point is still going to be bx minus c equals 0. So from the start, we're doing 4x equals 0, which is x equals 0. So starting point is 0. Ending point is going to be 4x equals 2 pi. So if I divide both sides by 4, I get x equals pi over 2. So that's my ending point there. Again, if I'm going fast, you're going to pause this video so you can catch up with me. Asymptotes, let's hold off on that. We're going to wait on that. All right, and the step is going to be the period divided by 4. So that's pi over 2 divided by 4, or think of that as 4 over 1. So that's pi over 2 times 1/4, which is pi over 8. All right, and now what are we filling in on this table? In this table is when we're going to actually graph the sine function, not the cosecant function. So I'm going to do 1 plus 2 sine of 4x in my table. All right, so I know that my x is going to start with a starting point of 0 and end with pi over 2. And my step is pi over 8, so I got to add pi over 8 here. Then if I add it again, I get 2 pi over 8, which is pi over 4. Add pi over 8 again, I get 3 pi over 8. Add pi over 8 again, I get 4 pi over 8, which is pi over 2. And then our next column header is not going to be cosecant, but it's going to be sine. So I want sine of 4x. And this is where I fill in my key values for sine. So that would be the values of 0, 1, 0, negative 1, 0. All right. Next column, I need to have 2 times the sine of 4x. So I have to multiply all of these values in the second column by 2. So I'm going to have 0, 2, 0, negative 2, 0. And then I need to add 1 to this. So this column header here is going to be 2 sine of 4x plus 1. So if I add 1 to everything here, I get 1, 3, 1, negative 1, 1. All right. Again, when we were looking for the horizontal asymptotes, the same rule applies. We want to look for zeros in the second column. I got 4 columns here, but I want to look at the second column, and wherever I had a 0 in the second column, that's where I'm going to have my horizontal asymptotes. All right, so I'm going to have horizontal asymptotes here at 0, and then at pi over 4, and then at pi over 2, and so on. So 0, pi over 4, pi over 2, etc., etc. So at this point, we're ready to graph this sine function first, which I'm going to do in blue. So I'm going to graph, again, clear all of this off. Now that we found our vertical asymptotes, I can just remind you that we always are going to be graphing the first column with the last column, right? So I want to plot 0, 1, I need pi over 8. Let's see. Let's go by pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8 would be pi over 2, 5 pi over 8, 6 pi over 8 is 3 pi over 4, 7 pi over 8, 8 pi over 8 pi's over there. All right? So if I'm filling this in, I'm going by pi over 8's on my graph. So I have 0, comma 1, pi over 8, I should be up at 3. Pi over 4, I should be at 1. 3 pi over 8, I should be at negative 2. I'm sorry, negative 1. So slide that point up right there. And pi over 2 is at 1. So if I fill that in again with a dotted line, this is our sine graph, not our cosecant graph yet. All right? And really should have done all of those. Yeah, can I just change that color on that? Let's see. Properties. Sure, let's make that like that. Okay, so hopefully that's a little bit better. That we can see my graph differently. And so I can keep that pattern going. And it looks like I go 1 to the right and 2 up, 1 to the right, 2 down, 1 to the right, another 2 down, 1 to the right, 2 up again, and so on. So my graph for the sine part of this continues. And it looks like I got 2 complete periods there, so that's good. And then I want to draw in my vertical asymptotes. I'm sorry, yeah. Ooh, big mistake there. My apologies. We'll get to horizontal asymptotes another time, like in chapter 2. They're not associated with trig. So I meant to say vertical asymptotes, right? Vertical asymptote at pi over 2. Vertical asymptote at pi over 4. Vertical asymptote at 0. All right, you could have just called them asymptotes, all right? Because that's the only kind we have here. So I'm drawing those in at 0, and at pi over 4, and at pi over 2. And it looks like if I see this pattern going, there's going to be another one at 3 pi over 4, and another one at pi. And at this point, I'm ready to draw in my cosecant graph. Again, it's just a hill coming up here like this, a valley coming up here like this, hill coming here like this, valley here like this, and so on. And we could keep this going. All right? So that's how you graph the cosecant function. All right? And I think, yeah, I got one last one for you. So let's do this one together. This one I gave you the whole kit and caboodle. We've got A is negative 2, B is a positive 2, C is a negative pi over 4, be careful on that one, and D is a negative 1. Amplitude, you're not tricking me, that's none. There's no kind of amplitude for cosecant functions. The period is 2 pi over 2, which is pi. Horizontal shift is the C over the B. Let's do this over here. Horizontal shift is C over B. So that's negative pi over 4 divided by 2 over 1. That's negative pi over 4 times 1 over 2, or negative pi over 8. Negative pi over 8. And then my vertical shift, I'm going to say, is down 1, because the D value. My starting point, to get the starting point, I want to do a 2x plus pi over 4 equals 0. So I get 2x equals negative pi over 4. And then if I multiply both sides by 1/2, I get x equals negative pi over 8. By the way, your horizontal shift and your starting point should always match, right? Even though we're figuring them out in 2 different ways, they should match. All right, and then the ending point, I'm going to do 2x plus pi over 4 equaling 2 pi. So if I subtract pi over 4 from both sides, that's really 2x equaling, let's see, 2 pi would be 8 pi over 4 minus pi over 4. It looks like I get 7 pi over 4. And then I multiply both sides by 1/2. And so I end up getting it looks like x equaling 7 pi over 8. All right, so that's my ending point. All right, and so we're going to wait on the asymptotes. The step is going to be period divided by 4. So that's going to be 4 is pi over 4. So I can fill in x here. My starting point is negative pi over 8. My ending point is 7 pi over 8, and I want to advance along by pi over 4, which, I mean, really, that's the same as 2 pi over 8. So if I want to add 2 pi over 8 here, I get a positive pi over 8. Add 2 pi over 8, I get 3 pi over 8. Add 2 pi over 8, I get 5 pi over 8. Add 2 pi over 8 again, and I get to my ending point of 7 pi over 8. All right, remember, what are we graphing here in this function, in this table? What are we plotting? Is the first thing we want to plot is the sine graph. So I actually want to graph -2 sine of 2x plus pi over 4. And then it was -1, right? So that's what we're really charting in this table, all right? So I'm going to put sine of 2x plus pi over 4 as my second column. I'm going to fill that in with my sine values, 0, 1, 0, -1, 0. And then I want to fill in, what do I need next? -2 times that is going to be my next column. So I need to multiply all of these guys by -2. So that gives me a 0, a -2, a 0, a +2, and a 0. And then my last column here is going to be that same -2 times the sine of 2x plus pi over 4 minus 1. I'm trying to squeeze that all in there. So I need to subtract 1 from everything here. And so in order to do that, I'm going to have a -1, -3, -1, 1, and -1. Hopefully I did that subtraction, okay? And so now I'm ready to graph this sine function here. All right, I'm going to graph that in blue, so I got negative. Let's do the pi over 8 thing again. Back up for a second. Yeah, I really should. I want to make sure that you guys all do this as well. I should change it on this side as well. So I went back to my graph here. That should be negative pi over 8, negative pi over 4, negative 3 pi over. Oh, that's not right. Start again. Negative pi over 4 over here, negative pi over 2, negative 3 pi over 4, negative 5. All right. And so here I want to do the same thing. I'm going to make this, pi over 8. Pi over 4, this is 3 pi over 8, then 4 pi over 8 is pi over 2, 5 pi over 8, 6 pi over 8 is 3 pi over 4, 7 pi over 8, and 8 pi over 8 is pi. All right, and I want to make sure that I do my left side the same way. All right, so I got negative pi to pi on my graph. And so I'm going to fill in these ordered pairs, starting with negative pi over 8 goes to -1. So that point, negative pi over 8 goes to -1 is right here. Pi over 8 is at -3. 3 pi over 8 is at -1 again. 5 pi over 8 is at a +1. And 7 pi over 8 is at a -1. So that graph is looking like this. All right, I could keep that pattern going. It sure looks like, it looks like I go over 2, down 2, then over 2, up 2, and so on. That seems to be the pattern. So I'm going to keep that pattern going over here. I'm going to go over 2, up 2, over 2, down 2, over 2, down 2, and so on. So there's a continuation of my graph here. And now let's go back, and did we ever talk about the vertical asymptotes? So the vertical asymptotes are going to be wherever we see a 0 in the second column. So that's going to be here, and here, and here. So I would say our asymptotes are going to be a negative pi over 8. Then the next one is going to be a 3 pi over 8. Then the next one's going to be a 7 pi over 8, and so on. So I'm graphing those, negative 3. Negative pi over 8 is right here, and then the next one's at 3 pi over 8, and then at 7 pi over 8. Again, it's wherever your sine graph is crossing through the midline, and in my mind, it sure looks like the midline is like right here, tiny bit, like right there, right? So it's wherever my graph intersects with that midline. And so at this point, I am ready to that. I am now ready to draw in my cosecant graph. I'll help if I drew in those. I must have lost my per class accounts. Negative, no, I have. I just didn't extend them over here. I need another one. Let's see. So I think the next one would be here, right? Okay, so now I want to have a hill coming down to meet that valley, or valley coming down to meet the hill. You get the idea. All right, and so my graph looks like this. All right. Again, you could graph a little bit more if you want. You get the idea of how this is working. I hope that's it for this video. Thanks for watching.